We'll now use the Turtle graphics package that we looked at in the last lecture to begin to discuss some ideas of inheritance. And the first topic will be how we use interfaces. Now, the word interface is usually used in one of two different ways. And on the one hand, an interface is a part of a software system that interacts with human users. It's like what you actually see when you run a program. Okay, on the other hand, it's a list of a class's public methods. In this unit, we're going to use the term in the latter sense. A class's interface provides all the information that we need to use that class without revealing anything about its implementation. Okay, that's one of the beautiful things about object-oriented programming, is that we can define how these classes will work without the user or without the client having to care at all about how we actually developed it to work, about what the guts of it, what the code inside looks like. Now, when related classes have the same interface, we can use them interchangeably in a program. Okay, so a good example of this is if you're painting a house. Little tiny, small, delicate brushes, you use them to paint around windows and doors, and then you use big, coarse brushes like the one on the left to paint big, vast expanses, big spaces on the wall. But really, you're using these different brushes, these different types of brushes, all in the same way. You dip them all in paint, and you wiggle them all backward and forward on the whatever thing you're painting. In other words, they have the same interface. If we have instructions for how to use one type of brush, we have instructions for how to use any type of brush. It applies for all of them. In the same way, if you have code for using a class, it applies just the same to all other classes that share the same interface. We're going to use this idea with Turtle graphics. The standard pen class that we used in the last lecture is one of 5 classes that all share the same interface, the same set of public methods that we use in the same way. Examples of 2 others are Wiggle Pen, which draws wiggly lines, and Rainbow Pens, which randomly changes the color as you draw a line. Now, even though these pens do something slightly different from a standard pen in terms of their wiggliness or their color, they have the same general behavior as a standard pen because they all share the same interface. In other words, we can use them in the exact same way, though we'll get different results. Okay, last lecture you saw this table, and I basically introduced it just as a list of the methods that a standard pen could use. And now we'll think of this as essentially the interface for a pen. Now, Java actually provides a more formal way for us to describe an interface. And you can see it in an example here, pen.java. This is an actual interface. You can even note we use the word interface here where you might have expected the word class. The code's really simple. It's just the signatures of the different methods, and after them, semicolons. This interface tells programmers all the information they need in order to use pens of any type correctly. Standard pens, Wiggle Pens, Rainbow Pens, any other kind of pen that uses this pen interface. Now, this isn't a class. I want to make that really clear. This is an interface. But when you define a class, we'll actually have a way to specify that class must conform to this interface. If it is a type of pen, it has to have a down method. It has to have a drawString method. It has to have a home method, and so on. Now, one note, the color class, which you can see here, we import it from the java.awt package, and we have a method called setColor that takes a color object as an instance. The color class is the way we represent colors in Java. Okay, so the class has a bunch of constants, including like color.white and color.black and so on. Now, those are for commonly used colors. That's just a helpful note. So let's look at a quick example. Here, we're going to write code to draw a square with 3 different types of pens. Okay, we import Turtle graphics, which we've added via... we import Turtle graphics, and we declare a class called testPens, and we're just in the main method here. We declare 3 pens. Now, this is interesting. These are not standard pens or Wiggle Pens or Rainbow Pens. We're declaring variables of the pen interface, P1, P2, P3. And then we instantiate 3 different types of pens: a standard pen, which conforms to the pen interface, a Wiggle Pen, which conforms to the pen interface, and a Rainbow Pen, which also conforms to the pen interface. And because they conform to the pen interface, we're able to point those pen variables at those objects, even though they're not specifically pen objects. We make those 3 pen objects, and then we draw 3 squares, which will appear in 3 separate windows. And we can see if I click Run, the 3 windows appear. Here's one, here's the other, and here's the other. For me, they appeared off screen, so I had to drag them on. For you, they will likely appear one on top of the other when you run, so you might have to drag them to separate them. Now, once again, I really want to drive this home. P1, P2, and P3 are all pen variables. That's the name of the interface. But those variables are associated with objects of these more specific, more specialized type of pen objects: standard pen, wiggle pen, rainbow pen. Each object responds to exactly the same method calls, the ones listed in the pen interface, but they do slightly different things. Okay, and again, it's the idea that we can send the same messages, we can call the same methods, we can do the same things with different objects, but get different behaviors as a result. Now, the code we saw before is a little redundant because we had 3 loops that were drawing the same square over and over again with different pens, P1, P2, and P3, one the standard, one the wiggle, one the rainbow. Now, if we know this is something we're going to have to do over and over again, then we can go ahead and just write a little method so that we can not duplicate that code unnecessarily. Here we'll write one method called drawSquare, and it'll take as a parameter whatever pen we want to use to draw. So you can see how we call it here. We make our 3 pens, P1, P2, P3, and then we call this drawSquare static method using its pen, P1 or P2 or P3 in this instance, as the parameter. We call drawSquare from main. It's got to be a static method, and it can take any kind of pen, including a standard pen or a wiggle pen or a rainbow pen or whatever else, as its parameter. Now, in general, where possible, you want to use an interface name if there is one. 2 big reasons for that. If we write a method so that it uses an interface type, it tends to be more general. So it's going to work with any class that implements that interface. So if we write a method that in order to work with a standard pen, well, if we assume that we're going to make it work with any kind of pen, then later on, it's really much easier for us to just substitute in a wiggle pen if we later wanted to. We don't have to actually change the code because we wrote it generally enough to handle any kind of pen. That makes it a lot easier to maintain. Right? If I wanted to change the pen type, I only have to change it in one place rather than changing everything in the method to handle a specifically different kind of pen. Using an interface where you can makes life a bit easier. Okay, so we just looked at interfaces from the client side. Here are the big ideas you want to take away from here. You want to know what's the purpose of a Java interface and how is it different from a class? That's a really important thing. How's it different from a class? All right, did you see any implementation code in that interface that we looked at, the pen interface? The other thing you should give a try is open up the drawSquare method in testpens2 in the code for this lecture and modify it so that it can take parameters for the pen, first of all, the coordinates of the square's upper left corner, and how long you want the side to be. And then it should actually draw that square, the corresponding to the inputs it took. That's it for today.